All right, guys, it is March 1st. We made it to March, Monday, March 1st, Virtual Monday. Um, some of you guys, well, most of you guys, I will see either tomorrow or Thursday because, as you know, the district is returning to the hybrid learning. High schoolers have been back for a week or two, but they kind of staggered the starts just like they did in the fall. We came back first in the fall. The high schoolers came back first now. But 7th, 8th grade will be back in the building starting tomorrow at like a 50-50, into two groups. So I will see you tomorrow or Thursday. But thanks to those of you who are on the call this morning on Virtual Monday. We're going to still be doing Virtual Monday every Monday. So every Monday at, 9 o'clock? Every Monday at 9 o'clock, you guys will still be doing Virtual Monday. So make sure you guys log in 9, 9:30, 10, 10:30, 11, 11:30, and noon to your 7 bells, okay? Because Virtual Mondays are still important. We get this 30 minutes to kind of introduce what we're going to do, answer questions, go over homework, things like that. So make sure you guys still attend Virtual Monday classes, even though we are back to school starting tomorrow. Thanks again for being here. I just see somebody else just jumped on the call, so let me update my attendance real quick. We are gonna finish up lesson 4-3. We started 4-3 and we didn't really get to finish the whole thing. So I'm gonna spend just the rest of our time this morning. We have about 12 to 15 minutes. I'm gonna spend this time just reviewing and finishing up lesson 4-3. So lesson 4-3 is talking about making predictions using the trend line, right? And this is the one we did on Thursday, where this data right here, we made a trend line, and you can see the trend line. I know it's zoomed out a little bit, but we zoomed in so you guys could see it a little bit better. And well, now it's not going to cooperate, but right, we figured out the slope of the trend line, right? We drew the trend line through the data, and then we figured out the slope of the trend line. And then we used that to make predictions, right? So the trend line is not going to be a guarantee, right? But it is going to be an estimate if the trend continues, which we would expect it to, right? We were talking about fuel economy in vehicles, and as technology gets better and engineers get better at making engines get more efficient, right? They use less gas, right? The average car in 1980 got 15 miles per gallon. The average car in 2010 got 23 miles per gallon, right? That's what this data is representing. Cars are getting better and more efficient as technology increases, right? So as this trend continues, we could project what a new car is going to, how much fuel a new car is going to use in any year. Like if this trend just continues up, we can project what we think will happen if the trend continues, right? Now that it may or may not be exact, but looks like we had a slope here. We had a rise over run. We have 2 points here on the line and here on the line. So looks like we rose from 15 to about 23. So our rise would have been 8 and our run was 30 years. So we go 8 miles. We increased 8 miles per gallon over the span of 30 years, and we could get a slope, right? And then based on the slope, we could calculate what we predict this to be in 2025. I won't do that again. We'll do a new one that we haven't done yet. So this scatter plot shows the relationship between the number of people at a water park and the temperature. About how many people should the owners of the park expect at the water park when the temperature is 90 degrees Fahrenheit? All right, so here is the graph. I'm going to try to zoom in a little bit on it so we can see it a little bit better. I just wish I could go over a little bit, but I can't. That's about as good as I can do because it won't let me go left and right for some reason. So you've got a scatter plot, right? and then they drew a trend line. With all the data, they drew a trend line that kind of goes right through the middle of the data. About half the points are above, about half the points are below. That's what makes a good trend line, right? And now we want to know how many people should they expect on the average 90-degree day. Well, on the average 90-degree day, we're just going to use the trend line here, right? Obviously, like on this day right here, it looks like it's about 91 degrees, and maybe 800, and these are going by 100s, right? There's 0, 100, 200, 300, 400, 500, 600, 700, blah, blah, blah. These are going by 100s each square on the y-axis. So it looks like this was 91 degrees and about 890 or 880 people came, right? This one, it was 89 or 88 degrees and about 820 people came. This one, 92 degrees and 810 people came, something like that. So we just literally use the trend line here. I'm going to look at where the 90 degrees is on my trend line, and that is about 800 degrees. Now I could actually, give me a second here and let me do this. Let's do it this way. I am going to why I didn't think of this earlier. But let's do this. I was doing this with the snipping tool the other day during office hours, helping a couple people do some work. So let me just show you what I'm doing here. I'm just using the trend line to make a prediction. The question asked us, if it's 90 degrees, how many people should the owners plan on having at the park? Why is this thing not? There's 90 degrees. Oh. It looks like it's just a little more than 800. Again, my artwork is not perfect, but it looks like it's maybe about 810. It's a little more than 800 right here. So based on the trend, the owners should estimate that there's going to be about 810 people that come to the water park if it's 90 degrees, okay? And they obviously want to know that because that determines how many lifeguards they need to have that day, how many concession workers they need to have that day, things like that, okay? Right? If it's going to be a cold day, they don't need as many lifeguards. They don't need as many concession stand workers. They don't need as many people to clean up because there's not a lot of people there. If it's going to be hot and there's going to be lots of people there because people like swimming when it's hot, then they need to have more staff, right? They need to make those decisions about how many people do we need to schedule. Or if we have a bunch of lifeguards scheduled and all of a sudden there's like a cold spell and the temperature's only 70 degrees, we can call a couple people and say, hey, you want to take the day off today? We don't need you. Where it's supposed to be cold, so nobody's gonna come, right? So does that kind of make sense? This was just using the scatter plot and just estimating, basically, making a guess about how many people are gonna come. Let's go to the next slide here. They did exactly what I did, right? There you go. They drew a line straight up at 90, and they drew the line straight over here. It looks like it's about 810. They said about 800 people, right? Because we're making an estimate. We can't say for sure, but it's about 800. I would say it's about 810. It's a little more than 800 people if it's 90 degrees, right? That would be our estimate. All right, let's go to number 3. Oh, let's zoom out. All right, they got a little video for us on number 3. So I am going to let you guys check this out.
The scatter plot suggests a linear relationship between two variables, the temperature and the number of smoothies purchased in thousands. Part A. What does the rate of change, or slope, represent in this situation?
So what does the slope represent in this situation? We know that our slope is unit rate, right? Our slope, our rate of change, our constant, our unit rate are all the same things, right? So this is smoothies purchased, and then it's in thousands, right? So this is 16,000, 32,000 smoothies, and this is the temperature, okay? So maybe this is like nationwide of a company like Smoothie King or whatever, or Jamba Juice or some smoothie company that has like hundreds of restaurants or hundreds of locations nationwide. As the temperature goes up, they sell more smoothies. That's typically the trend, right? People like to drink smoothies when it's hot because they're cold. So this is literally smoothies per degree. That is the unit rate there in smoothies per degree, right? So when it's really cold outside, when it's like, I don't know, when it's like 7 degrees, they did not sell a lot of smoothies, right? When it's 19 degrees, they do not sell a lot of smoothies. The hotter it gets, the more they sell, right? So that's literally what it's telling us, smoothies per degree of temperature.
The rate of change, or slope, describes the number of smoothies purchased for each 1 degree of temperature increase. How can you find the slope?
Well, in this graph, we can use these grid lines and find the rise over run, right? First off, we know our y-intercept, right? Here's the y-axis. So where does this line cross the y-intercept? It appears to cross the y-intercept at 8, right? Because this is 16. So 2 spaces was 16,000 smoothies. So it looks like one space is going to be 8. So we know right away, and I'm going to clear this. If we're going to write our y equals mx plus b, we know that right away our y-intercept is 8, right? The mx is the slope and the b is the y-intercept. So we know that this is 8. That's where the blue line crosses the y-intercept. Now we would need to find rise over run. So we need to find another point on this line that crosses at like a perfect intersection on the grid. And I'm going to pick this right here because it looks to me like this spot right here is right on 32,000 smoothies, and it's right at 40 degrees, right? We go up from 40, it's right there, right on the line, 32,000 smoothies. So my slope, I went up from 8 to 32, right? So I went up 24 spaces because 32 minus 8 is 24, right? So I went up 24 degrees, or sorry, no, that's wrong. I went up 24,000 smoothies. I went up 24,000 smoothies and I went over 40 degrees. So my rise over run would be 24 over 40. Well, we're going to have to reduce that, right? But that's a basic form. I know that 4 is, both these numbers are divisible by 4, right? 4 is the greatest common factor between these two numbers. I can factor out a 4 here and reduce this fraction. So my final thing is going to be 24 divided by 4 is 6. 40 divided by 4 is 10. You know, I could actually, 4 isn't the GCF, is it? Because I can divide out another 2, right? This is, we divide this by 2. That would be 3/5 is actually what that is. So what we're gonna get here is, sorry, erase this. If I reduce 24 over 40 into simplest form, I get y equals 3/5 x plus 8, or something to that effect, should give us the equation of that line. So 3/5 represents they go up 3,000 smoothies for every 5,000 or for every 5 degrees the temperature rises. Every 5 degrees the temperature rises, they sell 3,000 smoothies, right? Up 3 over 5, up 3 over 5, up 3 over 5. That's my slope.
To find the slope, begin by choosing 2 points on the graph of the trend line, such as the points with coordinates 40, 32, and 80, 56. The slope is equal to the difference in the y-coordinates of the 2 points divided by the difference in the x-coordinates. The fraction simplifies to 24/40ths, or 3/5. Part B. What does the y-intercept of the line represent in this situation?
There you go. They picked that point and this point. I picked the y-intercept in this point, but they still got the same rise over run, right? Up 24 over 30, which reduces to 3/5. All right, I'm going to finish this up. We got about 2 or 3 more minutes here. Let's finish the video, and I will dismiss you guys in a minute or two.
Equation. The y-intercept of the line represents the number of smoothies sold when the temperature is 0 degrees Fahrenheit. The graph shows that the y-intercept is equal to 8. Part C. What equation relates the temperature, x, and the number of people who buy a smoothie, y?
All right, so this is the equation that we already just wrote, right? We already figured this out. Y equals 3/5 x plus 8, right? Because we know the slope is 3/5 and we know the y-intercept is 8. So let's just wrap this up.
Use the slope-intercept form of a linear equation, y equals mx plus b, in which m is the slope and b is the y-intercept. The equation for the line is y equals 3/5 x plus 8.
All right, that's what we got, right? Because the starting point right here is 8. The line runs into the y-axis at positive 8, and then it goes up 3 over 5, right? It goes up 24 over 40, but we have to simplify that. Okay, so we got a little bit more done on this. I'm going to dismiss you guys now so you guys can get to where you need to be for second bell. I think all you guys go to Mr. Paris' class, so he should be starting his Schoology conference here in about a minute or two. I will see some of you tomorrow. I will see some of you Thursday. I can't wait to do that. I'm excited. And have a great rest of the day. I will see some of you guys later on in study skills. So you are dismissed. Thanks for being here.